we're going to move through this, and this one's pretty short. There's maybe 2 that are long for today, but for the most part, we're around like 4 or 5 steps or less for each of them. So we're going to go ahead and write down the given. Okay, so for our proofs, for the proofs of this section, you are either proving triangles are congruent, or you might be given a picture and you're proving a certain part of the triangle, that certain corresponding things are congruent. So it's just something to look at. Since we're proving 2 triangles are congruent, things that you're going to be looking for: side, 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 angle, side, angle, 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 side, side, angle, side, and if it says that you have a right angle somewhere in there, you can throw in that hypotenuse leg option. This one, I know, kind of looks like XY is perpendicular, or XZ is perpendicular to YW, but it doesn't say it, so we don't know. So we're going to go through one of the other options. Side, 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 angle, side, angle, 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 side, or side. Right, so okay. Things to note. It says that these 2 are congruent. That's part of our given. We also are told we have a midpoint. So, what do we know from a midpoint? Yeah, those parts over here are congruent. So when you have a midpoint, there's 2 options. You can either say that the segments are congruent, or you can say that they're equal. Which one would be the helpful part here? Congruent. So we're going to write it over here. And so when you're writing it, things to make sure you're paying attention to. If we say it's WZ, because remember with triangles, you always have to make sure it's the corresponding parts. So if you look up here, WZ, when you write the other segment, we want to write it that corresponding part. So W should be corresponding with Y, and Z corresponds with Z. So YZ should be the other side. Yes, I know ZY is the same segment, but you want to make sure you're writing it that corresponding part. Okay, do you remember what it was for our reason? Midpoint theorem. Good.
Can we say X is so then we can be side, side, side.
Say that, you said, can you say what?
XZ convert to XZ.
Exactly. Yep. We have this side that is a shared side. It's from both triangles. So, yes, saying that XZ is congruent to XZ from reflexive.
Is there such thing as like definition of reflexive?
We have reflexive property of congruence, reflexive property of equality, but that would be if it was an equal sign. Okay, and then look at our markings. I go along, and as I physically wrote that things were congruent, then I mark it on my picture. And so now we can see that all of our sides have been marked as congruent within the proof, which means we are done with the proof, except for writing our final statement, that triangle WXZ is congruent to triangle YXZ. Side, 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 side.
So once like you prove once you prove that all sides are equal, then you would basically prove it.
Yep. Yep. Or you can prove like your angle side angle stuff, whatever the different out of our 5 reasons that we had yesterday. As long as you can get to that, then you're good. Okay, let's look at the next one. Next one says 2-column proof. It's crossed out flow proof. We will get to flow proofs eventually in here. We'll spend a day on it, but until then, we're going to write our 2-column proofs like we have for everything else.
Are we ever gonna have to do a paragraph for this?
No.
What's a paragraph?
Where you just write the proof as a paragraph and sentences. We did it for like
Oh I remember.
We did it right before, like, we did it for a day right before we started learning proofs, but
I remember doing that. If we ever did that on the test.
yeah. If it doesn't specify what kind of proof, we can always do paragraphs if you want to. Paragraphs just tend to have more writing involved, so I don't write them in paragraph proofs often because I'm more of a step-by-step kind of person, not a write a paragraph kind of person. Why I teach math, right? Solving equations are just steps. Okay, so we know that RQ is congruent to ST. So what I like to do with here, like with this part, RQ, so R, and I put these little dots next to it, is congruent to, oh, never mind, not on that part. Going to the congruency statement, sorry, at the bottom part, where RU, so RUQ is congruent to TUS. I put those little dots to it just to like have myself in there for, yeah, so I know what's corresponding. So when it comes to writing my proof, I know what letter I have to write first or second or whatever. It's just helpful when it comes to that proof. Something else to notice, because when we do have ELT in here, we'll do it, which is tomorrow. We'll practice more of all, not necessarily proofs, but more of like what we were doing yesterday. You just have two pictures and like, are they congruent or are they not? Something to notice, the arrows mean congruent, or sorry, the arrows mean parallel. The dash marks, these little tick marks, that symbolizes congruent. So just making sure you know the difference. So those little tick marks mean that they're congruent. The arrow means they're parallel. You'll see that tomorrow. Well, you'll see some pictures tomorrow because there was a little bit of confusion with first period, so just to make sure. You'll see it tomorrow, I'll show you. How do you know? Okay, so we have our parallel lines. We're cut by a transversal. So this angle is congruent to that angle. So back to thinking about the parallel lines, we first have to state their alternate interior angles, then we can state their congruent. So that's when there are two steps. And since, if y'all look, angle Q is just for this one angle. Like there's no other angle you could create with the letter Q. So we can just label it as angle Q. And then same thing with angle S. Because sometimes we have to use 3 letters to describe an angle, sometimes it can just be 1. So angle Q and angle S are alternate interior angles. Yep. And then we can say they're congruent because of good alternate interior angle theorem. So far we have 2 things marked.
You can't do anything with like vertical.
You sure can.
Oh, you can?
Yeah.
Oh,
These are vertical. Now if you look at the letter U, that letter is making both of these angles. So that would be an example that we have to write the angles with 3 letters. So
RUQ.
yeah, so if we had angle RUQ and angle
SUT.
TUS,
Oh.
right?
Oh, right.
And angle TUS are vertical angles by our definition of vertical angles. So that means they are congruent by that vertical angle theorem.
Now it's done, right?
Okay, so we have angle side. Yep. Yep.
How would I know like what order? I never know what order.
So the thing to look for is the side. Is the side in between the 2 congruent angles or is it outside of it? outside. So that makes it angle, angle, side.
So why can't it be side angle?
I mean, that's the same thing. We just call it angle, angle, side.
So it would still be right.
Yeah.
But does the side usually come last?
No, because you have like side angle side.
Can I go to the next one? I'm gonna give you a warning now. This next one is our most complicated of today's stuff. I think even including that extra practice you'll have. So I'm gonna write up the given first, then we'll go through and talk about it.
Oh, it's like.
Okay. So it's one long congruency statement. They're all congruent with each other. And if you look at the picture, it's already marked for you. So all of these are congruent. What we are trying to prove, looking at your prove part, it's not stating two triangles are congruent, it's stating that two parts are congruent. So what's going to have to be used here is that we're going to have to prove some triangles are congruent and then use that CPCTC. Corresponding parts of congruent triangles are congruent. That's what we did on, we talked about it the other day. So the parts that we are trying to prove are congruent are right here. Which are little parts of those two small triangles of QRT and WUR. I don't know if it's in the right way. But it's of those two small triangles. So our end goal is that if we can prove these two triangles are congruent, then we can use CPCTC to then say QT is congruent to WU. Now to get to that, we can't just jump straight into it. We got to get that another step done. Yes, you got an idea?
Yeah, you could say angle TRQ angle WRU.
Okay, so saying that these two are congruent. Okay, that's going to be needed. Yes, fully on board. Before we just start writing it, I want to make sure that we have a plan kind of mapped out because this is a long proof. So if that were the case of what we figured out, we will need that. That sounds amazing. Don't lose that idea. What other part of those two triangles could we then say are congruent?
It doesn't talk about right angles.
Nope, we don't have anything about right angles. Is there a way to get to show, because since they don't say right angles, we don't know this angle, if they're both right angles, we don't know that part. We don't know anything about a midpoint. Well, okay. If we know it's the R is the midpoint, but it's just saying that R is the midpoint of that long SB part, or that Q or R is the midpoint of W or QW. Yes.
You can say lines at the last or QR. Just pull it from the given.
Say that again.
You can pull from the given and QR is congruent to that QR.
Okay, that part's good. But then we still need one more thing, right? So, do you have a idea? The line QT. We're trying to get that to be congruent. Oh, UT. What about UT?
Like on UR, say on triangle R SRU, right, and then URT, TR, same as.
We just don't know about these two lengths. Like we know about the other parts around it, but we don't know. So what I'm gonna suggest, because I'm gonna give a little hint. Because this picture is more than just those two little triangles, right? So that means that there's probably other things that are helpful. What we're gonna look at, instead of those two small triangles, look at these triangles. If we look at them as two large triangles, things that are helpful here. We know these are congruent. We know these are congruent. So we currently have two sides congruent. Can we get that central angle? Can we show that these are congruent? Okay. Why that is now helpful. If we do that, then we can use that CPCTC thing to say that this angle is congruent to that, which will get us to our third missing thing that we needed for the two small triangles. So we're gonna go through and do that part. Then I'll kind of show you why we had to do it. We'll go back to explaining. So let's prove that we have angle QRV and angle QWRS are vertical angles. Which means we can say they're congruent. By our vertical angle theorem. Which then means we have a side angle side of that triangle on the left. Side angle side, triangle on the right. So we can say the entire triangle of QRV is congruent to the entire triangle of WRS by side angle side. The whole purpose of that was to be able to create a way to show we have our angles Q congruent to angle W. Because of that CPCTC. Because now I'm going to go back and erase all this. What we were just able to prove is that these are congruent. What we also have that is congruent is this part. And then now, bringing back what we said from the very beginning, that I said, like, hold on to that idea. This angle and this angle are vertical angles. These two angles are vertical angles, which means they're congruent, which will then give us our third, or like we'll have all three things to be able to say the small triangles are congruent, to then have to use that option of CPCTC again. So, angle QRT and angle WRU are vertical angles. So they're congruent.
Are there gonna be more of these, or is it the only?
For today, I think this is the only, maybe different. But it'd be on your extra practice, your extra worksheet. So now we have angle, side, angle. And we get to say those two little triangles are congruent. Triangle. And then we are now, I know it seems like it's a wild one. We are done. And that final reasoning is C, P, C, T. Corresponding parts of congruent triangle are. I told y'all, I warned y'all before we started. This is a long one, it's our hardest one of class.
I don't get it.
So let's, here, we can go. We're gonna skip the next one on y'all's paper. And we're gonna go to this one. So find the one like this. It should be just the next one. So we just skipped one. Okay. Say B is congruent to BC, and then BD bisects angle ABC. So labeling that on your picture, AB congruent to BC. So we're good there.
So we're gonna, since it really bisects ABC, what A angle ABE congruent to angle BBC?
It will be, but when we talk about, so yes, with it bisecting, when we have a statement about bisecting, we don't have a congruency statement, we have an equality statement. But yes, same idea. So because it's bisected, we know that angle, the measure of angle ABD equals the measure of angle CBD by our definition of an angle bisector. So it's going to be two steps because we have to now use the definition of congruence to make it a congruency statement because we need congruency for those angle or triangles. So angle ABD is congruent to angle CBD. But yes, wonderful.
So you could say AS side BD is congruent to BB.
Yep, we have that shared side again. So that means we're going to be using that reflexive part again. And looking up here, what we're trying to prove, ABD is congruent to CBD, so BD and BD. So segment BD is congruent to BD by our reflexive property of congruence.
And then we use sides, both sides.
Side, angle, side. Yep. So we're done. Triangle ABD is congruent to triangle CBD by side, angle, side.
This is much better.
I told y'all that last one was the hardest one we got. The rest of them are around like this kind of length-ish.
Would that kind of thing ever be on like a pencil?
The 9-step one that we did? I mean, maybe. Would I have a lot of them? No, it'd be like one of them was like that. But okay. So I want y'all to do, where is it? Not that one. Let me find it. The very last one on your paper. So I want y'all to do this one.
Is it hard?
No. It's roughly 5-6 steps. About 5.
I put angle side. I mean angle side. Oh, that is.
Second word.
Why is it side angle side?
Here's angle.
So this part was our given, right? Then if you went the parallel line route, there's parallel lines cut by transversal. So these were your corresponding angles.
I just got that. Yeah.
Okay.
I thought A and C was.
But there's no transversal cutting then.
Then you can do the
And then the midpoint theorem is where we got that these two are congruent. So then looking at your label, side angle side. If you had step 3 and 4 as your step 2 and 3, that's fine. Like, if you put the midpoint, like the last part, you could have this around a little bit. Okay, so the rest of these, we're done for our stuff for